We often hear leaders and teachers talking about how ambitious and lofty the curriculum or standards are. It's like this is, and research also suggests this, right? That many people have analyzed the curriculum and really made the conjecture that there's more than 10 months of learning packed into all of those standards and expectations.
I got too many standards to teach.
It's a lot, and it often feels daunting. And so a move that many districts have made is to go through all of those standards or expectations and identify the high leverage ones. Some people call them the priority standards. It's like, these are the ones that, are critical, key concepts at this grade level that students need to develop mastery of in order to be successful long term. If you're running out of time or you're trying to use your time strategically, make sure that you are emphasizing these key concepts.
Yeah. Or like these are the key concepts that we want to and this is some of the other work that some of the districts that we support doing is which key concepts do we want to see stretch vertically? And then therefore we want to make sure that we're giving our students in those key concepts at that grade level, emphasize, certain strategies, maybe certain models that we know are going to be impactful to make sure that becomes the priority so that it carries on to the next grade level and the next grade level and the next grade level. I think people right now are going I know some of those key standards are for my grade level that do stretch vertically. So we can't afford to, be deficient in these areas. Or what it means is we know these are really important. Therefore, if we do have time to support teachers on standards, which standards are there? It's these ones.
Absolutely. I think the challenge, though, that many districts face with this work around priority standards is who's doing the heavy lifting to identify the priority standards? Who's creating the document, thinking about the learning goals? It's usually a small central office team. Because teachers who are teaching all day don't have the time to do this, high cognitive demand task. But just like we always say in the classroom, it's the person doing the work is the one who's doing the thinking and doing the learning. And so now I've created this document. I've identified this, we have, let's say, hundreds of standards in the main curriculum. Okay, now I've whittled it down to 10 to 20 that are absolutely critical. But what we're going to unpack here today is now what?
Right.
So we've identified them. But now, what's the next step to strengthen teaching and learning around these big ideas?
What does that look like? If I have to do professional development, or not have to, but if I get to, right? If I get to do professional development on those standards, how do I strengthen those standards up? That's the question.
Where we're starting to see some success is through really intentional use of embedded teacher collaboration time, or PLCs, where protocols are in place, where teachers come together collectively with a skilled facilitator, and the work that they're engaging in is sometimes, referred to unpacking the standard. But my question is, what does that mean?
What does unpacking the standard mean?
Right. And there's probably multiple ways to interpret that, but I'm just curious, and I'm wondering for this community, what does that mean to you to unpack a standard?
Yeah. Does it mean we're looking at the standard and trying to go what does it actually tell? What is this document that, is it actually saying, and how in depth do we go? I know here in Ontario, when we, the curriculum shifted, especially for the grade 9 curriculum, and it shifted and it was unveiled. There's this new curriculum since there was no textbooks to go with it. And at the time, it didn't go into, say, the specific expectations in depth. So it left many teachers and many school districts wondering, how far do we go with, this part of linear relations, or this part. So it's you had some schools at that time going very deep, and then some schools kind of being, in a way, not so deep. And it was because we weren't sure, because we were all interpreting, we're unpacking a standard and going, but how far do we take it? What is that standard specifically telling us? And here's probably what most districts and most schools end up doing, right, Yvette, is that they're we do have a textbook. Let's just look at that. And that's unpacking the standard and going, I'll just grab what someone else's interpretation of the standard is, and I'll use that because it's quick, it's easy.
So what we're going to do here today, John, is we're just going to, on the fly, unpack a standard together. Selfishly, this is for me because I need your support in unpacking this standard. So I'm going to put you on the spot. Okay, I've identified a standard for us. It actually originally stemmed from a conversation with one of our partners based in Louisiana. So I'm going to read you the grade 8 standard in Louisiana, but then I'll share the grade 9 Ontario standard that is basically the same thing. So in grade 8 in Louisiana, it says, know and apply the properties of integer exponents to generate equivalent numerical expressions. Okay. And here in Ontario, this comes up in grade 9. It says, analyze through the use of patterning the relationships between the exponents of power and the operations of power, and use these relationships to simplify numeric and algebraic expressions.
Got it. I'm
Okay.
ready.
So if I was going to unpack a standard, the first thing that I personally like to do, and as I mentioned, like there's not one way to do this, but this is just my process, is I like to start by identifying what is the student learning goal. What are we really asking of students? What's the lasting, enduring understanding? So if you and I were collaborating in a PLC, like this is our mock PLC right now, how would we articulate in student-friendly language what it is we're hoping to achieve?
And I think what your default is like, let me take the standard and just rewrite it so that the student says, by the end of the year, my students will know and apply properties of integer exponents to generate equivalent numerical expressions. Like that's the typical, I think what happens in, say, our PLCs is like, that's my learning goal, which ultimately it is your learning goal because it is the standard. We want that to be the takeaway that students can know and apply the properties of integer exponents. But I think we need to kind of go, well, what is the purpose here? Like the standard is written, but is there any sort of underlying component here that we want to have our students take away? Like what are those? I think you've used the term residue, like, or what is this belief or this just truth that we need them to have that's attached to this? Sometimes it's like asking, like, well, why is that important? What does it help our students kind of know and understand about, say, the relationships in mathematics? Ontario's description is a little bit more like, try it this way. It's like not say like, hey, just do this. It's like, do this, but make sure you use patterning, because we really are trying to like strategically guide you to not just teach the rules, because the rules are really quick, but then it doesn't get at like the reason, which is where patterning comes in for this particular standard. If like, if we can look at the patterns that are evolving, we can then generalize to make our own rules. And that's where Ontario's trying to go versus, say, Louisiana state standard.
So my question would be, we're working with all 4 operators. Okay, that's my interpretation of this standard. I think that what we want students to be able to do is to understand equivalent expressions for the purpose of simplifying in order to solve. So it's like, how can I simplify this expression so that it's more manageable for me?
Right. So
it makes more sense to me.
Yeah, something that always stuck with me is, and this is specifically about how you can structure your lessons as well, because that's part of you're unpacking the standards, so you can decide on what is my structure of my lesson that best helps teach the students that lesson or that learning goal or that standard. And I often remind of, especially when we are working in very abstract land, like where exponent rules sometimes tend to lie, is like, how do I teach this with context, or how do I teach this so that there is the patterning happening here that I can get my students to explore, which is, that quote, or a quote from Dan Meyer, which is basically, if math is the aspirin, what's the headache? And that part, if you can ask yourself that when unpacking a standard, sometimes can get at those pieces of like, well, what is the why here? Like, why are we exploring this? Because that can also help you structure your lesson plan to get at, if math is the aspirin. Like basically, if knowing and applying the properties of integer exponent rules to create equivalent expressions is the aspirin, what makes this like, why do that? Like what is helpful to do that? And that can, for us, that's always been like how you can develop the context of the problem if you're going to, say, bring in a lesson to support this standard and set the stage for that next move, but also helps you unpack the standard itself, because that's the key component here, right? Is like, we need to understand the standard ourselves and these answers to these questions so that we can then translate into students.
So part of our process would be to actually articulate, that learning goal, like you said, like, what is it? What is it we're trying to tackle here? What are we trying to enroute? Do you feel confident yet? Like, I feel like we're trying to pack this learning into a short episode, but I feel like I'm leaning towards something like, I will understand that. I don't even know if I want to say knowing, but using the relationships that exist between exponents and their powers, or it's like there's two things here, right? Like you have the relationship between the exponent and its power, but then also the operators.
Yeah, that's like basically what
It's
you're
like
trying to say,
two.
right? Is we're saying like we're using operations, specifically multiplying and dividing, with powers with the same base. So if we're
Mm-hmm.
multiplying, dividing powers that all involve the same base, how can I use my patterning that it exists in here to simplify expressions so that it's easier to work with when using those expressions? And that's the way that we always approach this when teaching it, right? Like you could just easily like toss this up and say like, I'm gonna walk you through these rules because those rules are really important. And I feel like I've done that in my old self. My first 10 years of teaching, I probably did that. Or my next iteration was like, you know what? There's patterning that's happening here. Let's multiply a bunch of threes together, and let's multiply then another bunch of threes together, and then say we're multiplying these two groups of threes together, and then see what the students can say, like, well, write the answer as a power, and it's like, can we see the patterning between how many threes here and how many threes here, and then write the rule after that, which is like a worksheet. Can you do that? What do you see as a total? Can you generalize? That was probably my next iteration. But then to get at like the power, like the reasoning here, it's like for a while there, I would just put up complex expressions, like 3 to the power of 2 times 3, times 2 to the power of 8 times 3 to the power of 6 times 2 to the power of 10 times 3 to the power of 1, and then I would divide and then it would be like all that divided by, and then another
Mm-hmm.
combination of powers of 2s and powers of 3s, and then I would just say, here's our warm up today, guys. Give me an answer.
Mm-hmm.
And it would always work out to like just like 2 times 3, or 3 times, just like very, very easy answer. And then we do that a few times, and then we're like, what's going on?
So I feel like, with all that said,
Now I went down a rabbit hole when we were like, I just want to know what the learning goal is.
well, this is what makes this work interesting and challenging, right? And I think that's why we're doing this episode, because this work is critical, but it's also, how do we structure it? Like if I'm the facilitator of this session where you and I are working collaboratively, what's the goal? So are we comfortable with saying, like, I will understand how to apply exponent rules to simplify expressions? Like that's ultimately what we're working toward as our long-term objective.
Yeah, like I think that's fair to say that like that is the learning goal from these two standards. But I think for me it is, if I get a little bit more in a way general, is that I'm simplifying, in a way you're just simplifying expressions or calculation. Like it's a calculation you're simplifying. And I think generally that's an overarching theme of algebra anyway, right? So it's like, what do we really like? Why is this any different than collecting like terms? Well, the bigger picture is we're trying to actually make this easier on ourselves. And
Right.
the rules of algebra were developed, the shortcuts were developed to make complex calculations just easier. So we spent a lot of time trying to simplify and write equivalent expressions, because that's another big idea that we actually haven't used the word equivalency here.
Right.
Is that you're really like, this expression is equivalent to this expression, and we're showing equivalency.
We're
And I
right.
think that is also really a big idea to include in the learning goal, is that we're building in equivalent expressions in the idea of equivalency between the different forms of operations.
Okay.
Numbers that involve operations.
So do we feel good with, like, I will understand equivalence in order to simplify expressions?
Yes, I like those.
I like that. Okay, now though, the next step I would want to take is, now I want our success criteria, which is like, what do students need to know, understand, and do for this to be successful? Like if I want students to understand equivalence in order to simplify expressions, and in this particular unit, we're focusing on exponents, what are the skills that they need to be successful? What do they need to understand? What do they need to demonstrate? So now we're getting into like our I can statements.
Right.
So what can I do?
So is this where you want to get more precise on the actual rules, but also like your demonstration of your understanding on the equivalence and using the operations in equivalence? Because to me, that's what I would be looking for. So my look for is can students can students look at an expression, use the operations to simplify it into an equivalent expression, but then also reverse engineer that? Can we look at, say, this, can I build an expression that's
Based on.
equivalent to this expression based off, say, the use of the operations that go along with making those equivalencies? Like, I want to know back and forth, whereas I think most of the time we're always kind of structured of like, take this, simplify it, boom, take this, simplify it, boom. And I want students to be flexible in knowing like when is the right time to kind of use some of those operations and when not to. And I think that would be useful. Like, we would be doing that with bases that, that have numerical bases. And we would also be doing that when we have algebraic bases
Right.
in, say, both of these grade levels.
So in order to construct this criteria, I feel like we would need a shared experience, right? We actually talked about this on a call this morning. It's like, rather than jumping into the success criteria, it's like, can we work through a problem together and talk through what did we need to know, understand, and do to make this successful? So here's our problem. We're going to do 3 to the power of 2 multiplied by 3 to the power of negative 5.
Okay.
Okay.
We're just going to do it.
We're going to talk through this. Like, it's like, what do students need to know to simplify this expression?
You
So
ready?
I'm ready. I'm prepared. You're the one who's on the fly here. I got to prep because I'm not as confident with this content as you are. So here's one thing that I know. It's like, I know that I can add the exponents. Right.
Know that because you already know the rule, though.
Well, this is what I'm struggling with. So it's like, I know that when I'm multiplying powers with the same base, you add the exponents.
Sure.
But I feel like students would need expanded form.
That's exactly right.
To see this.
That's how we teach it.
So I'm going to go up to our success criteria and I'm going to write, like, I can show expanded form. Because it's like, without expanded form, I don't know that we could arrive at these generalizations.
You cannot.
Okay, I'm going to add it to our criteria.
I love it.
I can write an expression in expanded form. So talk us through, like, how
the other part, like in this particular one, right? Like, you're seeing 3 to the power 2 times 3 to the power negative 5. We also have to realize that 3 to the power of negative 5, if you're going to write it in expanded form, like, you're like, how do I write 3 to the power of negative 5 in expanded form if I also don't know the rules to be able to do some of this, right? So you also have to know that, I could, I have to represent this maybe in a different way first, which means, like, I might not begin with this with my class.
100%.
This is not the one I'm going to begin with. So I'm going to begin with like 3 squared divided by, if not even going to begin with that, I'm going to begin with like positive exponents.
Positive and positive.
But if I'm trying to blend the two at that time, you're not going to have a negative exponent pop up here. You're going to be looking at, dividing powers. That's why I was saying, like, that version where it's like, I have a bunch of expressions on the numerator, I got a bunch of expressions on a denominator. Now what we're going to do is start to play with, like, how do I simplify this to make this easy? If we use expanded form on the numerator, I could simplify that complex expression into maybe 2 powers, because there's a power of base 3, there's a power of base 2. I'm referring to this example that I was describing, that I didn't describe in full detail, a few moments ago. So that we can see that we can be, we're dividing these two, and then I'll go like, well, how many power, like, if I'm all multiplying and dividing, like, I could start dividing, and making ones. Like, that was a big thing for us too, is like creating a 1. Like, where do I see ones when multiplying and dividing, and looking for ones? Like, that's a, I don't know if we want to put that in our success criteria for equivalence, because I think it's a really important component of, working and simplifying expressions, whether you're working in exponent rules or algebraic rules later on in, say, grade 11. Like, a vertical stretch is like, where do I see expressions that are equivalent, and I'm dividing them or multiplying them? If I'm multiplying and dividing in any order, like in a term, then if I can divide in any order, therefore I can divide these two to create a 1. And if I can create a 1, it's easy to work with ones, and 1 times anything is it's the anything. So that is the part where we build towards, say, writing the expression with negative exponents once we see some of the relationships between the rule of, say, multiplying powers of the same base, but we also would be unpacking like, well, what is a negative, like where does this negative exponent notation come from? Like why are we writing it in negative, like a negative exponent versus a positive exponent? Like why is it written that way? What does that even mean? So we've got to also unpack that so
Hmm.
for this to make sense,
Well, that was like my next thing was like a negative exponent means the reciprocal. Why? Like
Well,
why?
yeah,
Because again, it goes back to division.
of course.
Right.
Yeah, of
So like
course.
so if we were going to write this as a success criteria, okay, so give me some student friendly language to articulate what we need them to know, understand, or do.
For a negative exponent?
Well, even for like your idea of like finding opportunities to find one or helping them
Mm-hmm.
see division first before we move into this territory of negative exponents.
Gotcha. Well, I don't. Oh, this is always your expertise to write student friendly language. I guess I would just say is like I c- I can I can
See or find or
yeah I can see
identify.
expressions that operations or expressions that will calculate, that simplify or calculate to one
Mm-hmm.
is an important skill that I
For sure.
think we do. Now, this is also like an important skill that I think we think is important, because you're also, by knowing that skill, you can then explain other skills. And I think a lot of folks in teachers, because I didn't zero in on like this idea of like, can I simplify anywhere to a one until later in my career. Like it was because I unpacked the ideas of it myself. And how do I explain this to kids where we're dividing out? Because that became a dividing out, because people will say like, I'm crossing out, right? Or I'm these cancel each other. But what
Mm.
does canceling mean? Because that's what's happening when I divide 3 by 3, right? It's like I cancel a 3 and a 3, they cancel out and they go away. Kids think this is a magical expression that just happens. But really, why do they cancel out? Because 3 divided by 3 makes a 1. Where else can
Mm-hmm.
I make a 1? And that's also like, now I'm going to go down another rabbit hole, because it's a similar property. Like making ones with multiplying, to me, is the same idea as the zero principle when adding. It's like, it's not the same, but it's the same idea, where it's like, hey, these fundamental truths make it easy to simplify. I can divide these numbers to make ones, and 1 times anything is really nice. So it simplifies an expression by dividing things to make ones. If I'm adding expressions, then I can make a 0 by adding the opposite, or looking for its opposite and adding them together in a complex expression. That also simplifies. Like these are some really nice truths that make like that are built, like are some of the fundamental building blocks of simplifying expressions. So I don't know if I've done any of the
Well,
things that you need me to
yeah,
do.
no, I guess I'm wondering then if we need to be more precise in our success criteria, where it's like I can divide expressions that will simplify to one, I can add expressions to make a zero,
I like it.
right? So it's like we're getting precise about the behaviors, because that's one of the expectations, right? Is like the properties of the operators
Mm-hmm.
as well as the properties of the exponents. So that's where, like, when we're being precise about which operator this relates to, I think it helps us clarify our criteria. So, in the interest of, not making this episode 2 hours,
Somebody's leaning in right now going like, please do. But then someone else is leaning in going like, guys, sum this up
yeah,
already.
maybe what we have to do is offer, if anybody wants to get on a coaching call with us and actually engage in this work, please reach out. So, I'm going to just recap what we've done so far.
Okay.
So, I think that the first step is for us to come to a common understanding of our student friendly learning goal. We had an episode about alignment versus autonomy, and I think this is one way we can create alignment, is that if as two teachers teaching the same grade, we have a common understanding of what students are striving to around this objective. Then we need to take some time actually co-constructing a success criteria, and I think a great way to do that is by doing the math.
Well, here's what I think I appreciated about us doing this is that you are like acting as a skilled facilitator right now by trying to keep us on pace of going like, here's what we actually need to develop. Because I think what you're witnessing and what I'm witnessing right now is like, how do I write that? Because I have a lot, like, where there's a lot of knowledge floating up on teachers' heads, and their understanding of the standard, their experience teaching the standard, like it's all up here, and they're comparing that about what they have tried, what they have, what succeeded, what didn't succeed, what students did, what students didn't do, and we're trying to formalize that. right? And that's what you're trying to do right now, is you're trying to say, like, where are these formal components that I'm now using my facilitation skills to bring this out, so that we can have a common understanding of what is it we're really trying to do. Because if we're doing this in our PLC, that I'm spewing information about what I know about the way I've taught exponent rules and my understanding of them, another teacher is going to be doing that at the same time. And we do need that person to kind of go, what are we like? Let's make sure we're trying to capture what it is that we feel is important about this standard. And can we get that on
Mm-hmm.
paper? And I think that's that. If you're listening right now and going, we're all over the place, we structured this this podcast episode to be like that, where we are coming in going, we're just going to talk about how we've taught some of these things together before, but Yvette is here kind of trying to facilitate this process of, like, if I was in a PLC, here's what the structure is going to look like, so that we can get this out and we can kind of go, this is where we're going to try to go, and here's what this lesson could look like by the end.
Yeah, I think that you mentioned like shared understanding, but also common language. So
Mm-hmm.
again, like students that are experiencing math education within our system are experiencing, you know, a shared vision for what this objective looks like in the depth of the curriculum, like how rigorous is it, where are we taking this, but also the language is consistent across classrooms. So step one, we need a student-friendly learning goal. Step two, through a shared experience, we want to co-construct our success criteria, which articulates, really, it's like, I will know that students are successful with this learning goal if they know, understand, and can do these things. And I mean, that's why this would probably take more than this 30-minute episode. Like, this would probably take, an hour, a 60-minute PLC,
Of course.
potentially 50 minutes, because it's going to be messy. We're going to throw out a lot of ideas, but together we need to come up with this really precise language in a list. What I would do next in this unpacking is I would then go to our curriculum or our core resource. And I would ask myself, through a backwards design approach, how are they going to assess this learning goal at the end of the unit?
Good. Yep. I agree. Which is
Or
part.
look at a state assessment or
Yep.
some type of summative.
Yep. So it could be like your final test for the unit, if you have like one or a combined one that the department uses. I think that's an important component. So, or also, like, I think what many folks will do is go, what you're saying, go look at your resource and look at what, say, some of the practice problems look like, if you're not familiar with that is, because, and then is that tied to the assessment? Like, are we making sure that there's an alignment, there's a through line between all of these pieces? Because if my experience with my students is this, have I done, say, the necessary productive practice to make sure that I'm going to be assessing them the right way? And if not, do I modify the assessment, or do I
Mm-hmm.
modify my lesson, or do I make sure there's a nice through line between them, right? Because that's big. That's a big question that I think folks have, is like, I could teach through problem solving, or I teach through shared experience, where I'm not just doing all the teaching and we're kind of discovering some of these shared strategies, these kind of patterns that are showing up here. But then we want to make sure that we're moving towards, like, can I simplify these expressions? Can I simplify complex expressions? Can I simplify expressions with algebraic bases? Can I simplify multiple bases? Can I make sure that, I have all four, or all, say, three power rules, happening at the same time? Like, these are all different variations of what you're going to be doing, and that would show up in your assessment.
I think the reason that it's important to go to the summative is twofold. And you kind of mentioned that. It's like, one, can it help us strengthen our understanding of the rigor of this grade level expectation? So maybe we're going to use it to refine our success criteria to make sure that we are aware of what the end goal is, so that every move we make is helping position our students to be successful with demonstrating their learning at the end, but also keeping in mind that our resource is not the curriculum.
Nope, it is
So,
not.
like, I know here in Ontario, I think that the percentage is like it has to cover 80% of the curriculum. And it's also based on the interpretation of the person who wrote the resource at that time. So I think it's also, reminding ourselves that we are responsible for teaching our standards. In Ontario, we teach our curriculum expectations. The resource is a guide, but it's also, we can't trust it necessarily 100%, which is why we have to develop curriculum mastery, which is why coming together and having these conversations, doing the math together, looking at our state assessments or standardized assessments in the province, if we have access to them at that grade level, to kind of merge our understanding, the curriculum supports or the standard supports, as well as the textbook or resource that you have as your core resource. Okay, so, and again, keeping in mind that, let's say this is a 60-minute PLC.
Yep.
What's realistic?
Yeah.
Okay, so we've identified a learning goal. We've done some math together and we've talked about the success criteria. We've looked at a summative assessment to say, okay, well, how is this going to be assessed at the end of this learning journey? My final recommendation for this first meeting would be to pick a diagnostic assessment to take back tomorrow. So it's basically like, if we know that this is where students need to be by the end of this unit, by the end of this cycle, the first bit of information we want to gather is, where are they now? So can we as a team come up with
And what do you
a
do with that
common
data once you have
task?
it, right? Like, what
Right.
if you give your diagnostic, what are you now going to do with it once you know it? Is it going to change anything? Is it going to influence what you do next? Is it going to say, or not? Because if it's not, why are you doing it?
Mm-hmm.
Right? Like, is it just to gauge like growth, because you want to use the growth in the assessment when it's time to do, say, small group or say, the individual practice time? Like, if you're going to use it somehow, then go ahead and do it. But it is an important kind of question to make sure that you kind of see where kids now,
Mm-hmm.
because it could influence your decision about your lesson tomorrow. Like, you could be doing it and going like, oh, actually, I'm seeing this, this, and this, and now we're going to structure my lesson to be like that because I can value what's happening with kids already.
I think it's also helpful for our next time that we come together, because we know how powerful the formative assessment cycle is. And so if, when it comes to unpacking standards, we're also bringing student thinking and student work to the table, because really the work is not, I mean, I want to say this clearly. It's like, yes, we're teaching the standards, we're teaching the expectations, but we're also teaching students. And it's like, our goal is to take every individual student and provide the appropriate experiences for them to be successful at the end of this learning cycle or by the end of the semester around this objective. And so bringing the student learning to the table to do that co-moderation, we talked about in other episodes, like how important moderating assessment is. I think it's worthwhile when it comes to unpacking a standard, is that like we figure out where they need to go. We have a common understanding of what the outcome is going to be, but then we work together to target our instruction to be really responsive to the learners in our classroom, and we leverage our grade level partners to know what the next moves are, to help inform the instructional moves along the way.
Yvette mentioned, those other episodes, which were episodes, if you're keeping count, or if your podcast platform is sharing what episode numbers are, then those episodes are 361 and 362, two back-to-back episodes where we unpacked the structure of the PLC that we're talking about, and it's a multi-day structure. And what does that look like over time? So we're talking about like the beginnings of that structure, because coming back is like, let's look at the data, let's plan a lesson together. Like, we can be doing that work as well. We didn't talk about like the planning of the lesson or using the curriculum or modifying it to get at, say, the high quality vision of instruction that you want to be happening in your classrooms. Like, these are components as well. 361, 362. In those episodes in there, we've shared kind of a framework for how to structure those days. You can get on over there and download that so that you can see what those days would look like on paper at a high level. Yvette, anything else to wrap up here today?
I'm curious, reach out if you have a protocol that you use to unpack a standard. Like, I hear people say this all the time. They're like, we're going to unpack the standards. Mm-hmm. But I actually am not, like I said, completely sure what that means. Like, this is my interpretation and our interpretation at this time of what it means to unpack a standard. Also, given the constraints of staying within like a 50, 60-minute teacher collaboration period. But I'm curious what else is happening out there and what districts are doing that have been successful, because ultimately the goal we're trying to achieve here is curriculum mastery and strengthening teacher content knowledge. And so that's where it's like digging in, doing the math together, talking through and articulating and generalizing through the co-construction of learning goals and success criteria is a heavy lift, but also really important work.
Sure. For sure. And so if you zoom out, if you think about like what we're talking about here, about this, say, very specific use of your PLC time to do what Yvette just said, is if you zoom out a layer, if like this PLC time, it lives in, say, the bigger picture of the support you're trying to provide educators, the support as a teacher. you're trying to, also be involved in. If you're a teacher, if you're a coordinator, a math leader, you're trying to think about all these pieces. So for us, we view this 4-stage process, and coordinating and implementing, what we're talking about here lives in stages 2 and 3 for us. So building capacity is a really important stage that we need to be focused on the content, helping our teachers build their capacity, which for us is stage 3 in the content specific focus. Stage 2 is about thinking about your structures. So optimizing your structures, which lives in PLC land. PLC here is like one of your structures that you want to make use of. But, what we talked about here needs to be coordinated with any, say, large pullouts that you're doing with teachers, making sure that there's a nice continuation alignment between what's discussed across the district at any big PD days or kickoff days. Is the PLCs reinforcing that work? Do we see that there's a connection between that work? Because teachers need to see that, administrators need to feel it. And then are we now taking this a step further? So if we're doing PLC work, say collaboratively, and we're unpacking a standard, how are we supporting that in the classroom? In our one-on-one coaching environment, like are we going in there and talking about this particular lesson or this particular standard when we go there? Like is there a connection there? We need alignment across all 3 of these levels, which is kind of really important component of stage 2 in optimizing these structures and creating alignment, which also needs stage 1, which is your vision for high quality instruction that needs to be aligned across the district or across your school system. So these are the components that are kind of like, we talk something very specific today, but if you zoom out a layer and you zoom out a layer, it lives in this land of this well-coordinated, sustainable environment for math professional development. And those parts are really important. You can get a clear picture of what that looks like or sounds like as a whole if you head on over to makemathmoments.com/discovery, makemathmoments.com/discovery. You can see our pieces of the 4 stages and also get a glimpse of what that should look like for your school or your school district.